Let's read through this question together about a random sample of 95 halogen light bulbs that had a mean life of 531 hours. This is where you should be marking up your paper. 95 is your random sample. That is N. The mean life of that sample, we're talking about X bar, was 531 hours. These are our statistics. They come from our sample. We are going to use this information to construct a confidence interval at the level of 90%. We are given a sample standard deviation of 33. So in the state part, write down everything we know. We're given our statistics, X bar, and our standard deviation. Notice we do not know sigma. We do not have a reasonable estimate for the population standard deviation. It is unknown. And so when we are calculating the standard deviation of the sampling distribution, which is a formula on your formula sheet, we have to take, instead of using sigma, we have to use our best estimate, which is the standard deviation from the sample. So I have S of X divided by the square root of N. Here you can see that's 33 divided by the square root of 95. Now, because we have to estimate the mean, that with our statistic, X bar, and we have to estimate standard deviation with another statistic, which is that S of X of 33, we cannot use a normal distribution. We have to use the T distribution. The T distribution allows for more error in the tails. It has thicker tails, and that's because we're estimating not one parameter, we're estimating two parameters. So to use the T distribution, we calculate our degrees of freedom, which is based on our sample size, n minus 1. So n 95 minus 1 equals a degrees of freedom of 94. This is all in our state. This is all the things we know when we want to estimate the mean, the average life of a halogen light bulb with a 90% confidence. 90% confidence. All right, next we go on to the plan part. These should seem very familiar. We did these with sampling distributions. We have to check that we have an approximately normal shape. I know we're not using a normal curve, but the T distribution still has to take on that unimodal symmetric shape. So in order to do that, either we have to be told that population was normal, or we have to check with the central limit theorem. Here we're going to start by just looking to see that our sample size is definitely over 30, so we can use the central limit theorem for normality. The second check is for independence. We were told it was a random sample. Also, it is safe to say that 95 is less than 10% of the population of all halogen light bulbs. Notice how I write that out. You can't just write N is less than 10% of population. Give the context. So with conditions met, we will calculate a one sample T interval to estimate the true mean length of halogen light bulbs. Right, the next comes the do. And so much of this is on your formula sheet, but it's written in words. To calculate the confidence interval, you take the statistic plus or minus your critical value times your standard error of your mean. Well, we already know our statistic. We wrote it in the state. That was at 531. And then our standard error, we calculated that in the state, the 33 divided by the square root of 95. What we don't know yet is our critical value. And this is where your T chart can become really useful. You are given degrees of freedom, but it's not going to have exactly that 94 degrees of freedom on the T chart. Right? That T chart doesn't have every single degrees of freedom value. So the other option is using your calculator, and that's what I've modeled here at the top of the page. If we use inverse T, we can work backwards to find that critical value. Inverse T, I used 0.95 because the area to the left of my tail, even though it's a 90% confidence interval, I've got 5% in that tail. And so the older models of the calculator, you have to do area to the left of your critical value. So notice I put 0.95 in for the area to the left of my T-star. And then my degrees of freedom is 94. And then inverse T, 0.95, 94 gives me a T-star of 1.661. So to calculate my margin of error, I have plus or minus T-star 1.661 times the standard error, and that gives me a confidence interval. Once I do those calculations, I add the margin of error and subtract the margin of error of 525.376 to 536.624. Last step is to write up our conclusion in context. This is similar to what we've done with proportion. We are 90% confident that the interval from 525.376 to 536.624 hours captures the true mean life of all halogen light bulbs. Make sure you put your answer in context. Remember, our confidence interval is created to capture the true mean. We start with a statistic. We started with a point estimate, our X bar of 531 hours. And from there, we're able to create this interval that says we're 90% confident that this interval does capture our true mean. I hope this helps.